Hi, welcome to an Arduino step-by-step course by Robojax. In this tutorial, we are going to learn how we can use the L298N motor controller driver module, this red module, to control two DC motors in terms of speed and direction. I've written a library for this. Controlling DC motor will be very easy. Here it shows motor 1. Both motor will run with DC speed at 3 seconds, and then again we are using 70% for motor 1 at clockwise, counterclockwise, and for motor 2 50% at clockwise. And now at clockwise. Now I'm going to show you how you can control a single motor and use these two full bridge of this in parallel to increase the power. The single motor code. This is now slowly increasing up to 100. Let's get started with this. I've written a library for L298N module to control one DC motor or to control two DC motors. Also, I'm going to show you how to use two full bridge in parallel to increase the power of a single motor. In this tutorial, we are going to cover the following topics. First, I'm going to explain the L298N module. Then I will explain the full and half bridge. And then I'm going to show you the wiring. After that, the code will be explained. Then the demonstration of a single motor. After that, I'm going to demonstrate two motors. Then I'm going to show you how we can use two full bridge in parallel to increase the power. Now let's learn about this module. This is sold on eBay or AliExpress and Amazon at different prices. In the driver block diagram for L298N, we have four drivers here which receive very small signal and amplifies it as the output, so you can control a motor. Each driver has an input and an output. For example, for 1 we have input 1 and output 1, for 2 input 2 output 2, and the same way for 3 and 4. We have a full bridge A that can control one motor fully. We have one enable A, and then we have for enable B. For the two half bridge, we have one enable B, which can control another motor. The module is based on this dual full bridge motor controller module, and because if you use it like this, you have to put a lot of components and wiring, and also besides for the diodes there will be so much wiring. This is the best solution with simple connectivity and relatively very cheap. Maximum voltage that you can connect to this module is 35 voltage at the input. Then can fully control two motors with 2.5 ampere. That's the rated current, and then you can supply 5 volts power from this module to your Arduino. For example, if you connect a 12 volts motor, the input will be 12 volts and it will also supply 5 volts for Arduino. You can connect a 24 volts motor, doesn't matter, up to 35 volts motor you can control with this module. This is a half bridge. Half bridge will allow you to just turn on and off, or also control in terms of speed. So it has N, which gives you a signal, and also it has enable. So you will send the signal of 5 volts in here, and also you must enable this pin, which means you have to have also 5 volts to make the output provide 5 volts or whatever voltage that you connect. So this will need, the chip also will need separate voltage, which will be the same voltage as your motor. If your motor is 24 volts, you will connect 24 volts as a power supply. If it is 6 volts, you can connect 6 volts, 5 volts, whatever voltage it is. So this half bridge will turn on and will control the motor. So in this case, you can turn on and off the motor, or you can control the speed of motor by sending pulse width modulation to one of these pins, which in this case I'm using the enable pin. And if you want to control motor in two directions, then you need two half bridge. So we are using one half bridge, so this will be positive, and the other side, instead of going to the ground, will go to this other half bridge. So these N1 and N2, now we have, for both we will have one enable, which is called in this case for this chip enable A. So we have N1, N2. Whatever signal we have at N1, the opposite will be at N2. So let's say this is 5 volts, this will be 0. If this is 0, this will be 5 volts, and the direction of current will change, and the motor will rotate either clockwise or counterclockwise. The speed will be controlled with enable. If you set this to 0, the motor will stop. And we can use two half bridge on one side, so we have one full bridge here and we have another full bridge. That's why this is called dual full bridge. We can control fully two DC motors with speed and direction of rotation. Enable A for half bridge A, and then we have N1, N2. So for each full bridge we have 3 pins, and then we have N3, N4, and then here we have enable B. To receive the module, it will have this connector here, a jumper between this enable A and enable B with a pin. For DC motor, we will just remove it so we can control the motor speed as well. But in our application, the library that I have written, we will be using this 2 for one motor. Both wire of the motor will be connected in here, and in here will be another motor connected. Here we have this pin labeled as 5 volts, and this is a ground. This is labeled as 12 volts. That's incorrectly labeled. The voltage of your motor will determine whatever voltage you have. Let's say you have 24 volts motor, you can connect the 24 volts here. The 24 volts will come to this regulator. This is 7805. This is a 5 volts regulator, and here's a data sheet for this 7805, and we have 7806, 8.5, 9, 12 and 24 volts, and we are using only the 5 volt version in this case. And they have different pin configuration. This is the one that is installed on this module. This is a chip. Let me hold it the way it is on that data sheet. So this is the one. Input is on this side, output is here, ground is this heatsink. As you can see, maximum input for 5 to 18 volts is 35 volts. So this can accept up to 35 volts, this chip. And as you can see here, this capacitor is labeled also as 35. So you can connect 35 volts here. The 35 volts will come and it goes here and convert it to 5 volts, which will supply the voltage for the logic of this. And then the 35 volts also will go to this device to supply to your power to the motor. So the motor power will pass through this. So, and then from here we will have 5 volts available at this pin that you can connect it to your microcontroller or Arduino in this case. So Arduino will be turned on when you apply power here. For inductive load, for each output we need to have diodes, and the diodes are already available. So these are Schottky fast switching diodes. Here is a data sheet for L298 module. When this is at this shape, it's called L298N, and the package is called multi-watt 15, and if it is this type flat, it's called Power SO20, but we are using this one, and this is the block diagram how it is. And maximum voltage for power supply, it can be 50 volts, but because in this module it has been used with other component, it can accept only 35 volts. I will provide you the link in case if you want to read further. This is the wiring diagram to connect L298N motor driver module with 2 DC motors. We will connect 2 DC motors at these terminals. This is motor 1. The polarity doesn't matter because it will determine the rotation of direction of motor. So if you are unhappy with one way of connecting it, connect it the other way, and this is motor 2. For power supply, you can have a 6 to 35 volts battery. The positive will be connected to this terminal, which is labeled incorrectly as 12 volts. you can connect up to 35 volts here, and then the negative will be connected to GND or ground. From ground we have one wire that must be connected also to Arduino, to the ground, and then from this 5 volts, this 5 volts will be supplied from this module to Arduino, which will be connected here. Then at these 6 terminals we have enable A, input 1, input 2. These 3 are for motor 1, for this motor, and the 3 on the other side, N3, N4, and enable B is for this. This is as if this is motor B, enable B. So pin 1 is connected to 2, N2 is connected to 4, and enable A is connected to 3. The reason for that is that 3, you see there is a tilde, this is a pulse width modulation pin, and enable must be connected to pulse width modulation. And then for the other motor, pin 3 is connected to 7, and then we have 8 connected to N4, and then enable B is connected to pin 9, and that is coincidentally come into order because 9 is pulse width modulation pin. And if you're connecting single motor, just remove the motor and remove the 2 wires. Everything else is exactly the same. Let me now explain the wiring. I've connected one DC motor to this terminal, to these 2 terminals, and I've connected another DC motor to this terminal here. So 2 motors have been connected. Now here I have the power supply or my battery at this point, which is connected to my external power, and this is the ground. So I have these 2 wires available to be connected to my battery, and then from ground and from this pin, which is 5 volts, I have these 2 wires. Both of these will go to Arduino to supply Arduino with 5 volts when this is not connected to computer. So I will connect the 5 volts from this side. I will connect this 5 volts to the 5 volts when it is not connected to computer at this side, at this pin, and ground will be connected to the ground. So this will supply the input voltage will come here, let's say 12 volts for the motor. It goes, and from here 5 volts will go back to Arduino to supply 5 volts. This pin is enable A. Using this pink wire, it has been connected to pin 3. As you can see, there is a tilde, and this is also there is a tilde. It shows that this pin is pulse width modulation enabled. If you connect it to a pin, if you connect it to a pin that doesn't have a tilde, for example 4 or 2, it will not work. So that's very important. And then N1 here is connected to pin 2, the gray wire, using the gray wire to pin 2. N2 is white, have been connected to pin 4. Want to control only one motor, these 3 wires must be connected to these pins, or you define another pin somewhere else accordingly in the code. And here now, this is for the second motor. This is N3, N4, and then enable B. N3 is connected to pin 7 using blue wire. N4 is connected using green wire to pin 8, and enable B or ENB is connected using yellow to pin 9, which is pulse width modulation enabled pin. When you connect the power here to program it, and if you connect your external power, make sure to remove this 5 volts while you're working or programming. So I'm not connecting this 5 volts. Let me now explain the code. I've written the library for this L298N. You have to download the zip file and the link I will provide it. Once you downloaded the zip file, click on Sketch, add include library, add .zip library, and then point it to where you have saved the zip file. For example, this was the zip. If this was the zip, select it and click Open. Now the library will be installed. Then close your Arduino and reopen it, and after that click on File, Example, scroll down until you see Robojax L298N DC motor, and then click and open L298N DC 2 motors. Click and open it, and this will be the sketch. I've explained it how to use it, so there is documentation for that beside this video, but you need this video to understand it fully. this line says include this header file Robojax L298N DC.h. This is a DC motor header file which is part of the library, and then we are defining N1 and N2, that's for the one full bridge with enable A. We are defining pin 2 and pin 4 for input 1, input 2, and then pin 3 for enable A. Remember, this pin must be pulse width modulation enabled, and then pin for motor 2 we have N3 and N4, and also enable B. I have defined these pins. Again, 9 is also pulse width modulation enabled, which has on the board that tilde, so that means it has pulse width modulation. Keep that in mind. And then we are defining it as a constant CCW and CW, counterclockwise and clockwise, and these are the values. Do not change it. So we always use CW and CCW instead of 2 and 1 inside the code, so it can be understood easily. And then we are defining text 1 for motor 1 and 2 for motor 2. So we will use this text motor 1, motor 2 instead of 1 and 2 inside the code. Do not change that. File, we are creating an instance of it as an object. We call it motor. This is to control 2 motor, and this is to control 1 motor. Right now this has been commented, and this has been commented, have been removed. So we pass in 1 and 2 enable A, this is for 1 motor, and then we pass in 3 and 4 and enable B for the second motor, these 3 for the second motor, and at the end we put comma true. When you put this true, it prints the debugging information on the serial monitor. For example, if I open it now, this value is due to this true here. If you don't want the debugging information, remove the comma and remove the true, and it will just work fine, because after developing and connecting everything, then you don't need the serial monitor to just waste the resources. And if you're using single motor, this is a code, N1, N2, enable A, and then the same way, either with the comment or without the debugging information on serial monitor. Oh, I will have separate code that it's already uncommented for you. Inside the setup, we are initializing the serial monitor with 115,200 baud. If I open the serial monitor, and then on the right side, if you click here, these are the value. It must match. For example, if I select something else, you will see that the value is not readable. It must match. It has to be 115,200 exactly as this value, and then we initialize the motor by using motor.begin. So this will take all the values and set them as an output and set the proper values for controlling the motor. Inside the loop, we start using the motor very easily. We say motor because we have created this object, so now we are using the motor, and then motor.rotate we use, and then we pass the value motor 1, and then the amount of speed 60%. You don't worry about the other value. So this is human readable and understandable between 0 to 100%. 100% means full speed, 0 means stop. And then CW, this is clockwise. And if you want the motor to rotate to counterclockwise, just change it to counterclockwise, and this is controlling motor 2 and for 3 seconds. So the both motor will run with this speed at 3 seconds. And then when you want to apply brake, motor.brake, there is one way that you can send 0. This will stop the motor very slowly. It takes a while. But if you use brake and then 1, this will stop the motor 1, and brake 2 will stop the motor 2 and keep them stop for 2 seconds. And then again we use 100% for CCW for motor 1, motor 2 for 3 seconds. So these are demonstrations, so you know how to use the code. And this is a for loop. This is the motor control motor 1 with a speed of I and CW. I is a value that is from 0 to 100%, and this will increment it. This means add or increment to I. I start with 0, it becomes 1, 2, 3, up to 100, and this line will run with a delay of 100 milliseconds. So this will control the motor up to 100%. It will slowly speed up to 100%, and then at the end it will wait for 2 seconds and then apply brake to motor 1 and motor 2. Remember, motor 2 was running here without any stop, and then again we are using 70% for motor 1 at clockwise, counterclockwise, and for motor 2 50% at clockwise, and you can do whichever way you want to control two motors. If you want to stop both motors with single brake, just put brake and 3. This 3 means not 3 motor, but it means stop both motors. And if you want to use a single motor, click File, Example, Robojax L298N DC motor, and select single motor, which is this code. It's exactly the same, except I've removed the input 2, 3 and 4 and the definition for motor, so it makes it simple, and also the other code is removed. We just pass N1 and 2 enable A with a true, and the rest is exactly the same as before. Code is uploaded to control two DC motors. Let me now disconnect this. I'm connecting my external power here and making sure that this wire is connected to 5 volts, so Arduino also gets power. Now that is connected, let me connect my power supply. The power is connected. These two motors will start rotating, and here there is no power, and the battery is connected. Now when I was demonstrating it, I need to see serial monitor for some data. For that purpose I need to connect back the power. To connect the power, I'm disconnecting the 5 volts here and then connecting the power, and once that is connected I can connect this and open the serial monitor. Here it shows motor 1 slowly rotates, it reaches 100%, and then motor 2 is at the 100. Both of them braked, and one is running, the other is at 70%. 50% will not make this run. Now I'm going to demonstrate it with this larger motor, and the debugging also will be displayed, so you will see that for certain value of percentage the motor will not run, depending on the type of the motor. For example, some motor might start rotating at 10% or 20% or 50%, so you will figure it out and see when the motor will rotate. I'm now connecting the power. Now it's at 60%, motor is running. 70% you will see, and now it will go from small amount. You see it make buzz but still not running. At 50 it starts rotating. And now at the clockwise. Again it goes back to the beginning. And in 1, this is 1, in 1 is connected to N4. And N2 is connected to N3. So 2 and 3 are connected, 1 and 4 is connected, and the output 1 is connected to output 4, output 2 have been connected to output 3. So we have only one output on this side. Now I'm going to show you how you can control a single motor and use these two full bridge of this in parallel to increase the power. Let's say if this motor was 2 ampere, now when you connect this in parallel, you can connect a 4 ampere motor. You can control a 4 ampere motor, so the power will be doubled because we are using two full bridge in parallel by connecting this output to this output and one more wire from this to this. So these are parallel and the output of the motor is exactly the same. So the power of this side also will be used on this side. We are connecting this enable of this side, enable A to enable B, N1 to N4, N2 to N3. So we are using all of those. This way we can use it in parallel. The datasheet also says to use it in parallel. Prepare these wires, and I'm using this pink for enable. Let me connect it. I will connect this one enable and another enable. I'm going to connect this to N1 and N4, the gray. So this gray have been connected to N1 and N4. Now N2 and 3, the white will be connected there. So all of them have been connected. As you can see, enable A is connected to enable B, and the two white are connected 2 and 3, and then gray 1 and 4, and they're all connected together. And on Arduino, I'm going to use the pink for pulse width modulation pin 3. I'm going to use the gray for pin 2 and white for pin 4. I've now uploaded the code for the single motor because you don't need any setting or change in the code, except the wiring is like this. So the two full bridge are in parallel. Only one input is connected because we are controlling only one motor. The signal comes for one motor and the driver is being used in parallel. So code is not changed. Now let me connect that. So I'm disconnecting the computer and connecting this wire. Please make sure to subscribe by clicking at the subscribe button in here. Thank you. Thank you for watching the tutorial from Robojax. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos.